Hola chicos, welcome to another Learn Electronics Repair video. I've been asked a few times recently in the comments, would I do a 10 series GTX repair video? I said sure, and I've got one. This is one of the ones I actually bought back in November, but for various reasons didn't get around to look at them all. And it's not a GTX 1080, it says on the box, it's a GTX 1070. That's what it was sold as, and that's what it actually is. It's a GTX 1070, which is what I bought, so that's fine. This is one of the 13 cards that I bought, 10 from one guy, and then the other 3 were from individual sellers. So we looked at one of these a couple of days ago, which was the R9-380X. And that's now waiting for a FET and then a fuse, and hopefully we might get on working. So this one cost me £67.50 English pounds in the UK. Bit of postage on the top, so it actually came to £70.70. That's what I actually paid for it. The guy said on the listing it's spares or repaired. He says this is working, then it started to artifact, and then it just went off and blank and no video, no picture. And it's interesting it's come in a 1080 box. I'm wondering if possibly this guy's being very straight and honest, and he's upgraded, you know, he's bought himself another card and got himself a used probably 1080 and put that in instead, and then sold this one. So that's the story. I mean, I don't know how truthful that is, but I do believe that we're going to find out. So it's EVGA, same make as the whatever was in this box, and there it is. So there's the graphics card, not quite as big as impressive as some, not as heavy, but still, it is, in actual fact, a GTX 1070 8GB. I'll just zoom the camera down, we can have a look. Okay, so there we have it, GTX 1070. We can take this apart, I think, and let's have a look to see how honest this guy was. I mean, I'd say it's been off because of the markings here. And I could be wrong, because you'd have to slip a lot to do that with a screwdriver, but okay, who knows. Yep, let's get it apart and let's have a look, see what's inside this one. Okay, so there's just 4 screws that hold this together, so we can have a look. The first thing I can say is it looks clean. Yeah, it looks like nobody's been messing around with the heatsink compounds or putting more on or anything like that. So let's take the fan off and let's have a look to see what we've got on here. And I think the best thing we can do is I'll just brush some of this dust off it first, and then we can get it under the microscope. But I will say, actually, with this one, it looks, in fact, there's dust on it and such. I don't initially think anybody's been particularly working on this before me. Let's have a look. Okay, I've just taken this plate off as well, and I don't know if that's like something's hot and kind of burnt into it here. Oh, you see that? So that sits on here in this position. So the one that looks the most like it was kind of like possibly burned. Let me just see. Oh no, it just comes like a hole through here. It doesn't go to anything. It's like a hole there. I don't think that's any particular relevance. Okay, so we'll take that off there. And now let's have a look. The second step's then resistance checks. So we'll start with the incoming voltages. So we have on the first 3 fingers 12 volts, and there's no short on there. That's reading about what we'd normally expect it to read, a few kilo ohms. Fourth one in, 1, 2, 3, 4, 3.3 volts, 300 odd ohms is that. I'll angle this so you can see it and I can see it as well. If it's just 300 odd ohms, that looks normal. No, 5 No, it's kilo ohms. Okay, fine. 80, 90 kilo ohms, I wouldn't worry about. 12 volts at the end here. Let's not make the mistake I made on the previous one. Which side's ground? Because the other one's kind of upside down. I think this is ground on this. No, that was like the 12 volts. Let's go in here. So that's ground underneath. Or if that pin was ground. That pin's ground. Is this pin ground as well? No. So ground is on the top. On those two anyway. Strangely. That's ground. Okay. So I would say anyway there's a coil here, and this is going to be just an inductor, and it'll connect to here. If this is the 12 volts, whichever was the 12 volts. Find it in a minute. Now connect to here, and this will be coming into the various regulators. So let's see. But there's no short on it. Okay, there's no short. This, I mean, I'm not familiar with these cards, even though they're such common cards. It's the first time I've looked at one. This probably a 5 volt, just guessing. And that appears to have a short. So there's the first problem we can see. This appears to have a short circuit on this coil. Okay. V-core. This might have a shorted core. That was, but I'll try to on the resistance meter. That was very low to me. Yeah. This one would probably be PEX. Is this reading short as well? Yeah, I'm pretty sure this board's actually got shorts everywhere. There's another one up here. Okay, that's reading 5 meg. Where's the RAM? Well, it looks like these 4 phases of the GPU, and this phase is probably the RAM because it's different from the others. What's on that one? 100, 107, 108 ohms. Okay. This is definitely gone. I can see it now. Anyway, look. If we just zoom down on this, you'll see. So this has a faulty GPU, and it's the first one out of this batch that I've found that actually has. And if you look at it there, you can see this is like bubbled. Yeah, this is bubbled. So this is gone. This is gone on this one. Okay. Well, you can see it under the microscope. That's for sure. So yeah. That's gone, and this is all starting to come a bit clear now. So we can see this. What I thought was metal is actually plastic, yeah. And where I said this looks like it's something burnt, and this sits underneath here. So basically, underneath here, the hole is where that burnt thing was, yeah. So that suggests to me that somebody has been in here with a heat gun and basically subjected this GPU to too much heat. Okay, so I think a few things are coming clear now. I'm surprised I didn't spot this actually when I did the visual check, but I think honestly I wasn't actually looking at the GPU for some reason. So you can see this GPU's gone, it's bubbled, yeah, that's definitely gone. And this is all starting to become clear now, and we can do a bit of detective work, and we can say exactly what's happened to this card. So as I noticed before, this was the big clue. This is not metal, it's plastic. Well, like metalized plastic, it's plastic, yeah. And we can see that this fits underneath here. This is where I said, oh, something's burnt here. And then I sort of went, oh no, well, it just fits underneath these holes here, so that fits there. And it doesn't look, you know, like there's nothing there, but you can think now, so this guy is a dishonest seller. It's the first one I think I've come across so far out of this batch of 13. This hasn't just like artifacted and then give a blank picture. Somebody's been at this with a heat gun, that's quite obvious. And they've done it with this backing plate still on, so obviously that's melted that. Yeah, that's how that's happened. Doesn't take Sherlock to work that one out. Okay, so the question is then, what do we do about it? Well, first of all, I need to look at this GPU because the markings are odd to read. GPU 104. Is that something then dash A1? Just give me a moment and let me just go have a look and see if I figure out, look up what GPU actually this is. Yeah, okay guys, so it's GP 104-200-A1. I've looked that up, and now looking at it I can sort of make out the remains of the 200 here, so that's what that is. So I think the fate of this card is going to be down to how much is it worth and how much is one of these. So let's have a look and see. So the big question now is, before we do that, has this... I'm not going to call him what I was going to call him. Has this amateur, who clearly doesn't know what he's doing, managed to destroy the PCB under here? Yeah, that's the thing. Is the PCB flat? Now, he hasn't damaged it badly enough that you can see any bubbling on the reverse of it. And he hasn't damaged it enough that I can see any damage around here. And we know this melted the plastic behind here, so he's obviously used far too much heat. So let's get this chip removed, and then let's have a look to see what the PCB is like. If the PCB is in good condition, then I think we should just replace this one, and I think we'll have yet another repair out of the 13. If I fix this one, then so far we haven't had a single one that's failed us, yeah? Okay, so let's get you ready to remove. Yeah, just a bit of flux, and we just let this melt basically so it runs down behind the chip. Okay, it's going. You see, it's just. The idea is this, it will run down actually behind the chip itself. So go to this side. And normally I go around each side twice. So I rotate it, and then I rotate it again. And each time we just get the stuff to go behind it, okay. Okay guys, so the graphics card's on there, it's centered. I use the laser to center it. We've got the bottom nozzle underneath quite close to it, and you can see I've got the little pillar supporting the board. Just move this one in. This is just to effectively stop the board from flexing when you actually rework it. That's just touching it now, and then it's just mounted on the little things at the end, yeah. So thing is now is to choose a profile. So we go to choose, they call them curves on this machine, choose curve, and then these are various ones. I've got various lead-free profiles. Lead-free stubborn is for just heavier boards basically with normal components. I programmed all these myself, by the way, just trial and error. So lead-free LGA is for removing LGA sockets, and then LGA Gamer is the same thing, LGA sockets on gaming motherboards. Gamer mount requires a little bit more heat to mount them, I found out, when you want to put the new socket on. Probably because it's not in full contact with the board. And then this one, GPU remove. But I programmed this, as I remember, on a GTX 780s. Yeah, these are 780s. So whether that's the correct profile for this board, I don't really know. I mean, the way to tell would probably be about the mass of the board, you know, compared with the other ones. But I think that's the one I have. So I'm either going to have to use that one, or I'm going to have to start programming another one. And now's not the time to start programming another one. So we'll go with that one, GPU remove, back. And then I'll tell it to run, and let's see if it actually wants to do it. So it's just going to... so this has a top nozzle, which is hot air. It has a bottom nozzle, which is also hot air under there. And then these large plates, this is infrared heating. Yeah. That's like your preheater. So it's going to go for it. I've shown you before, but if you haven't seen it, so the coloured lines here, the red at the top is the upper hot air, the green is the lower hot air, and then IR, that's your infrared, and then the turquoise one is the sensor which I've put on just by the chip there, yeah? And you can see, so these are the various heaters heating up, and the turquoise one is what's actually on our board. And we can see the sensors up to 70. So I'll leave this running a little while and I'll come back when it's getting towards the temperature it needs to desolder. So you can see it actually goes up in steps, yeah. Can you see how the upper and lower hot air have plateaued there, yeah? And then it sort of waits at that temperature while the board warms up, so you see the turquoise one's coming up. And then after a little time it'll go again. Yeah, see them go up again, the green. And the red practically with it is going up again. So this will go up several times until we get to a high enough temperature to actually desolder it. Chips at 135. Okay, let's pause it a bit more. The trick with this, I mean, you can see the bubbling over the chip now, yeah? The trick with this is getting the right profile. Simple as that. I mean, once I start the machine, there's very little I can do. I can hit the emergency stop. But basically, one of three things is going to happen here. Either, first of all, it won't be hot enough and won't desolder the chip. Okay. Secondly, it'll get too hot and burn the board. And the third one is, well, there's four things. The third one is it'll get almost hot enough but not quite. And it'll remove the chip but strip some pads from the board, usually towards the corners. And the last one is that it'll actually get it right, it'll remove the chip. This is lead-free solder, so it's 193. And you need to get to about 235 to desolder. But I found that I actually have to get a bit hotter than that to actually do it properly. Okay, we do 197 seconds. I think this profile is about 5 minutes in total. So let's just pause it again. I'll come when we get a bit closer to ready. Okay, so we up another step. You can see the hot air, 249, 250. Okay, the profile runs for about 300 seconds roughly. The board's now at 210, the heater 191. So effectively this will kind of go to like a final push up and then desolder, and this is where we want it to hit the sensor 235, 240, 250. Okay, it's not hot enough. You see, in this case that profile isn't hot enough and it just hasn't lifted the chip. So what I need to do now is let this cool down, increase the temperatures and create another profile, and then see if we can actually get this chip off the board. So at this point, actually, I've made a bit of a mistake with the machine, and I've done this before and never quite figured out what I'd done wrong until I reviewed that bit of video off the phone, and I can see what I've done wrong. So when I chose the curve for the profile, the curve for the GPU remove, I actually then hit back to go back and start the machine, and I didn't hit the select curve button, so I was actually on the previous profile, which is the one we used a week or so ago to remove. We were removing PCH off H81 boards, so you can see that profile was absolutely textbook perfect for the PCH, but it wasn't for the GPU. It was too low. So now what I've done, I've not realised a mistake. I've increased the temperature on the profile of the BJ, thinking it needed to be hotter, which it didn't. I was on the wrong profile, and I've tried again. So you're now going to find out if I actually get away with it or not. Okay, let's do it for the second attempt. Okay, so we'll have to try again. But I think what's happened here is I think it's slightly lifted that chip, you know, which doesn't really bode well for what's happened to the board. But obviously it wasn't hot enough, so I've created another profile. Let's go to curve select, and I'll show you what I've done. So I've made this one GPU remove 1070, and I've increased the last two temperatures by 10 degrees each, and the time where it says 40 was 30, so I'm going to be 10 seconds more and 10 degrees more, because I think that was actually very close to working last time. So we'll use that one. I'll just check we're on the right one. Yep, we are. We'll use this one. I'll just go curve select. Okay. Remove. Choose curve. Yep, that's the one. It was already on it. remove 1070, confirm, back, and let's just run this one. So this is what I say about this sort of work, it's trial and error. I mean, the next time I see one of these, I'll know which profile to use. The question is whether or not I destroyed the board with the wrong one. Okay, let's let it go. So it's down on there, the start is running. I'll pause the video and then let's have a look to see when we get closer to the time. So once again, we're ramping up the temperature. I mean, all this first part of the profile until the last two steps is actually the same as the last time, so we wouldn't expect anything different to happen here. The difference will come to the end. Do we get enough temperature on the turquoise sensor to lift the chip? Okay, so we're getting further in now. You can see it's ramped up here. So we now have the sensor at 238, so we've definitely got more heat. I can see the chips bubbling away there, so we're getting close to the point. It looks to me like we've got enough. Now the question is, have I over-egged it? No, we're going to get too much at the end. If it goes up to about 270, 280, I'll probably start to burn the board. But as I say, there's not a lot we can do. We have to just wait to see whether this is going to pick up this chip or not. So this is the last push that I gave it. Yeah. Board 257, 258, that's not too hot, 260, so this is the last one I think, and then it's going to actually try to lift the chip from the board. Okay, let's wait for the bleep and let's see what happens. I think it's going to come up any moment now. The suspense, as they say, yeah, the suspense. Board's at 272, so that's getting really towards as high as we'd ever want it to be. Come on. Some point now. It'd be nice if this machine had a kind of like a manual, you know, finish the profile button, but it doesn't really seem to have that. No, I've definitely over-egged this. And I'm wondering if the first profile was actually wrong. If I was on the wrong profile, because this is running much longer. Okay, well, we're here now. It's bubbling away. I think somewhere in the next 20 seconds. We can see we're much further in. Let's go for it. Board's at 302, so that really is quite hot. Let's go for it. Come on. Okay, here we go. Well, we've got the chip. We've got the chip off, that's the first thing. So the question is now, how did the board do? It looks pretty good at a glance. Okay guys, so let's let that cool down now. And you can see the temperature's coming off. Well, it stops now, it stops displaying. The sensor's still showing it's dropping quite rapidly now. Okay, let's wait for that cool down and then let's see what the result was. So you can see in that second attempt, I actually realised as it was getting further on what I'd done wrong the first time. The original profile I thought I used, which was like 10 degrees cooler than that one on the last two steps and 10 seconds shorter as well, would have been fine, and we would have ended up with like the board at about 280. Even that might have been a bit much, but you have to get quite a bit of heat in these to make sure it lifts properly. I mean, fortunately, this chip was dead, so it's not that I need to reball and fit this chip. I mean, that would have killed the chip, I'm sure. But it looks like it's come off clean. I don't see any kind of orangey pads on the back of this, unless maybe here. We'll have to have a look under the microscope now. If I see like an orangey one, I know it's lifted pads off the board. So let's look at the chip first, then we'll have a look at the board afterwards. I'll get the microscope. So here's the chip. It's come off cleanly from what I can see. So I don't think we've taken any pads off the board. The question is whether the board is still flat. You know, have I actually kind of bubbled the board by that mistake I made on the profile? So yeah, that looks, you know, I mean, obviously it's a dead chip. You can see just how dead this is, but that looks like it's come off cleanly. So let's get the board and let's have a look to see what condition that's in. So this is the board, and I need to clean all this flux off to have a look, which I'm going to do in a moment. But at a glance, it looks pretty clean. Yeah, I'll just get this old flux off, and I'm obviously going to put some fresh flux on, so we need to effectively get all these old balls off the board. But just look at a glance, I think I got away with it. But that was kind of like as much luck as judgment, because I obviously made a mistake, and I know what mistake I made now, so I should be watching out for that. And hopefully I won't be doing that particular one again. But you can see, guys, just how tricky this can be. Press one button wrong, this can be a disaster, yeah? I'll also just mention, as you can see, if I just get it one moment. I'll just switch back over to the other camera. This is the top nozzle on the machine, so these are interchangeable. I've got several of them. I have 4 of them, I think, in different sizes. But this is actually the largest one I have, and you can see it's only just big enough for these. It's not really big enough. It's also not really big enough for LGA sockets, but they are a bit smaller than that. So I really need to get onto LY and ask them how much for a larger nozzle. I probably want one that's about 45 to 50 millimeter, I think. I'll probably get a 50, and I think that would probably help in getting the heat around the edges of this, and then I wouldn't have to get quite so much heat in to make sure I've actually melted it all properly. The lower nozzle, just take the lower nozzles off the machine. So this is a 50 by 50, and I think, in fairness, what I probably need to do is get another 50 by 50 at the top as well, make them the same size. Another nice thing with this machine, by the way, you can alter the temperature of the top and bottom nozzles separately as well, which is something I might actually try more, running the top one hotter than the bottom one on the final push. Anyway, that's a bit about the machine. So let's clean this off here, and then let's see what we actually got here. So first of all, I'll just get this old flux off here, because it'll be quite hard now after it's been so much heat on it. So we'll just get this off here as best as I can, and then we'll put some fresh flux on, and we'll start to clean up the board. And then let's see first of all if we've actually managed to get this off here without doing any damage, basically. Okay, so that's basically clean. Should have cleaned a lot of that up. Just get a bit of kitchen roll. Okay. Here we go, just clean that off there. It looks pretty good. Okay, so we'll now look at cleaning this up. So the way to do this is, first of all, to apply fresh flux to the board. Okay, so we'll put some fresh flux on the board itself. Okay, try and spread this around a bit. The easiest way to do that is like with a paintbrush. I have one I particularly use for doing this. So we'll just spread that around. Okay, and now I'm going to clean this up with leaded solder. This will generate quite a bit of smoke. I don't have an extractor, but I do have an old PC fan. I'll just get it. Moment. It didn't fall on the board, fortunately. Okay, so this is like just a 12-volt power supply. You can see it's a shrouded fan off some kind of Dell or HP computer, something like that. So all I can do with this is just place it to the side of the board so it blows the fumes away from me, and I find that's fine. I find that's all I need in the way of extraction. You know, just send the fumes the opposite way. So that'll do for that. Next trick now is to just warm the board up. So I'm not going to melt anything like melting the soldering. I just want to get some warmth into the board to make it easy to clean this up with the soldering iron. So we'll just give the whole area of the board a warm up. They might have to do this a couple times during the process. So the flux is kind of gone like liquidy now, so that's enough. So next one then is to take a soldering iron, BC3 tip, a nice big one. to move the blow a little bit away, and leaded solder. Okay, this is the stuff I use, 0.7mm. And now I want to form like a ball of solder on the end of the soldering iron. So I just go to one corner and like keep pushing solder in, so I get a nice big blob of solder. Yeah. And once I've got the blob, what I literally want to do this is kind of like hover it over the board. I'm not exactly touching it. I'm just kind of like hovering the thing over the top of the board. Yeah. And what this will do was effectively will like mix the leaded solder, which I'm adding, with a lead-free solder, and lower the melting point of it. As you can see, as I'm going across, the ball's getting kind of bigger. So at some point or other, I need to just take that off the board. Yeah, and just go again. So we'll just repeatedly do this. Solder in. Thanks to a guy named Diff, or DIIF, on Bad Caps, is the guy who actually taught me how to do this a couple of years ago. If the ball starts to stick to the board, which it was just doing then, what I need to do is to just get the hot air again and add a little bit more heat to it. So we'll just give it a little bit more of a warmth. And basically I'm just going to do this going around the whole chip. So because it's a bit boring, I'll pause the video now, and then we can have it when I've finished. But I'm just going to continue doing what I was just doing over the rest of the board. Okay, so I've pretty much been over the whole chip now with that. That's just the first step, and you have to be very careful as you're doing this, by the way, because if you don't get enough heat into it, you can quite easily strip the pads off the board. You know, if you lose one of these pads and it's a necessary one, that's pretty much game over. Yeah. So again, it's a matter of just keeping enough warmth into it. It might be a good idea to actually do this when the whole board is warm coming off the machine. I actually removed it last thing before I went home last night, so it's actually cold. So just get a bit of warmth in there. Okay. So now take a piece of braid. I use this stuff. Again, it was guys on Bad Caps who told me to use this. Before I used this, I couldn't do this. I could not do this before. And then we want a pair of cutters, and we're just going to chop a small piece off this. If I just find where I put my cutter, they're around here somewhere. Aha. Okay, so we want like about that much, yeah, about that much. We get about that much of this braid on there, and then we get flux onto that. And because it's cooled down a little bit, I'll just warm it a bit more, just to keep the temperature nice enough. You could do this with the thing sitting on a preheater, by the way. That's another way to do it. And there's many different techniques. It's a matter of finding the one that suits you. I can only show you the way that I do it. So that's that, a bit of heating again. And then a little bit of solder on the iron, onto the braid. Okay, and we start to just very gently move this around. I'm kind of like floating it almost, if you like. I'm not putting any pressure on. I'm letting the soldering iron touch it, but I'm not putting any pressure on the braid. And so I'm just floating this across the BGA. Okay. When it's getting full of solder, we get rid of it. We take another one, and we do the same. So we'll do one more, and then I'll pause this video again, and I'll go over the rest of the chip. You might notice the ones in the middle is where all the power planes are, so you often need to get more heat into that area to do it. So again, just warm the area where we're going to be working, which is this part. Okay. Again, bit of fresh solder on the bit. Onto the braid. That fresh solder is important. That makes a good contact between your soldering iron and the braid, so that the braid is at the same temperature as the end of the tip. You go a little bit more actually. Okay. And once again, we just gently, if it stops moving, take the solder line off, come back and heat it, or put some hot air in. If you feel even the slightest bit of resistance, like you hit a grain of sand, just stop. Yeah. Again, if you lose any of the pads, then it's game over. Okay, so I'm going to continue doing this over the rest of the BGA, and then we'll be back when I've done that. Okay, so that's done. I might have missed a few, but the best thing now is to get the flux off it, and let's have a look to see what we've actually got. I mean, you can always come back and redo the areas that you've missed if you have missed some. So again, isopropyl alcohol, and plenty of it, and we'll clear all this flux off the board. And then, for the first time, we can really see if we've got a workable PCB here that we can actually fit a new BGA. So just let it dissolve the flux on its own. Don't, you know, I'm not putting any great deal of pressure, I'm just dabbing it around. This flux will have gone quite hard, so it takes a bit of time for it to dissolve. Yeah, no rush, guys. But I will pause the video again and we'll come back when I've finished. Okay, I've done that. It needs doing again, to be honest. I haven't completely cleaned it off, but we can have a look at this. So let's zoom down and let's see. I definitely need to go over it again, because you'll see as we look across it that some of the balls are still actually on the board. What I'm looking for now is any ripped pads, and I don't see any. Normally, if they are, they're in the corner. I can see a few down here that, like, you can see some look very flat, and in some cases there's actually still balls attached to them, which need going over again. I'll point some out to you in a minute. Yeah, there's definitely some here. Let's find my tweezers. Okay, so you can see, yeah, like this row here. Some of these have still got the blobs on them. Yeah, can you see them? If it just tells you a little bit. There's a very good example just there. Okay, that one. And a little row of them here as well, you can see. Yeah, that little row. So, and these obviously ones, that when they look flat like this, they're done. Now, I was going to say it was like a rip pad, but I think it's a via. I think that's a via for this one here. So I think that's okay. So we can just go along, have a look. And that all looks clean. Yeah, so definitely we didn't rip any pads. Whether subjecting the PCB to too high a temperature really has damaged anything internally is anybody's guess. Okay. Yeah, you see this area, it hasn't done. I needed to get more heat in. I think to do this middle area, I need to get the graphics card sitting on the preheater, get up to about 100 degrees from underneath, and then go again over with the braid and the flux, as I was just doing, yeah, to do this. I haven't got enough heat to do it the way I was doing. Okay, so that's our board. Now then, let's have a think about this repair. So clearly somebody's fried the GPU on this. It didn't just fail. That also explains why these things were melted here as well. Not only did they fry it, but they didn't even take the backing piece off behind it, so they couldn't have possibly used a preheater. So what were they thinking? I just don't know. But anyway, what we can say for certain is he fried it because it wasn't working. Now, was it not working because of some problem with the GPU, or was it not working because something else was wrong with it? Because if they don't have the sense not to at least do that properly, then they don't have the sense to check the thing out properly. Yeah. So let's have a look. Can we determine if there was anything else wrong with this board? And I think, yeah, we probably can to a point, yeah. So first of all, we can look to see if there's any shorts anymore. Like, was there a short on the V caused by a bad capacitor? And we're reading now, you know, into the kilo ohms, yeah, that's charging up the capacitors, obviously because the thing isn't there anymore. On the VRAM, we should still read the RAM phase. And that reads high to me. because you expect the RAM to still read as the RAM does. Okay, fair enough, the RAM is no longer connected to the GPU, so there isn't a path to ground via the memory controller anymore, so we can give it that. So it's possible it would read higher. In fact, actually, I've got a couple of cards here without the GPUs on. It'd be interesting to see what the RAM phase reads on them out of interest. But let's keep going around. So there's another little one here, which I think was the PEX or something like that. This is way by the short, yeah. And there's no longer a short here. There's another one down here. There's no short on that. That's just a filter on the 12 volts. So shorts we've got rid of. That's the first thing. Let's have a look at this higher reading that we would normally get on the VRAM. And the best way to do that is I have a couple of donor boards. Let me just get them. Let's have a look to see if these will tell us anything. Okay, so this is a donor board. Which if I get a GPU I could fix. I mean, you can see it's quite nicely removed, as good as the one we just done, probably a bit better than the one we just done, to be honest. So with this one we can go the RAM phase, I'm guessing, is probably up here. No, actually the RAM phase is over here on this one. It's these two. What are you reading? You see, that reads how you would expect it to read on the RAM phase. Yeah? About 100 ohms. Let me get another one. This board, another 780 Ti, was actually working to a point before we removed the GPU. So this one had artifacts on the screen, okay, and I removed the GPU on this one. Actually, I think I intended to reflow it, and I told the machine to do the wrong thing. That's what happened. So let's look at this one and see again if we just find where the RAM phase is on this one. Well, a good guess is with these capacitors on over here somewhere. Yeah, 150. That is. So it's kind of reading similar to you'd expect the RAM to read. And our board, very suspiciously, is reading a lot higher than you'd expect it to read. Okay, I mean, this is a different board. It's a 1070, but having said that, I'm not convinced that's a good thing. I was intending with this board next to see if we can prove that the memory controller to here, that all the connections are good. So what I was thinking of doing is see if I find the data sheet for this chip, and then we find which balls go to the RAM chips, and then because we can get to the balls here, we can effectively check, probably on diode maybe best, or maybe resistance, effectively all the data address lines that go to each one. And if they all read the same, we can probably say the RAM's probably good. If some read different, we can say the RAM is bad, in which case it probably becomes uneconomical to try and repair this one. So let me go see if we can find a board view. That would be ideal. If I can't find the board view, let me see if I can actually find the data sheet for this and work it out from that. Okay guys, I hope this records properly. I'll check in a moment before I publish it. So basically we have, this is part of the board, yeah, and I've just minimized this. I hope we can see this. I'll just minimize it. So this basically, this schematic is just a 1070, completely different make and a different layout to ours, but we know this chip is the same, okay, for any 1070. And these are the RAM chips, and this has 8 RAM chips and mine has 8 RAM chips. So I've just clicked on one of the RAM chips. You can see the pins here, and you can see these like FBB D33, D32, D40, D41 and so on, yeah. These will be the data lines, okay. You can see them going down, lots and lots of them, and also these DBs, there's another one, D37, D36 and so on, okay. So my thought is that if I click in this first one, which I have done, you can see where that is in the RAM chip, and you can see where that actually is on the BGA. Yeah. So if I can, hopefully you will see this. Right. You can see on the BGA you got a block of 5, then 2, 2, 2. And on the third one of 2, the fifth one down, is the pin, okay, that goes to the RAM. So I'm on the meter on diode mode. So what I'm going to do is I'm going to find that pin on our chip. So we've got 5, 2, 2, the third set of 2, and then the fifth one down. Yeah, 1, 2, 3, 4, 5. And it's reading 0.63, 0.64 on diode mode, okay? So we know it reads 0.64. So if we go to the next one, again, I hope you can see it's there, yeah? So you've got 5, the second block of 2, and the third one down. So once again, I can find that pin on our chip. So block of 5, second set of 2, this side of it, third one down. And it's reading 0.637, so that's extremely close to the other one, yeah? So if I go down all the data address pins from each of the RAM chips on here, if I find any that read different, widely different from the other ones, the chances are that tells me I've got a faulty RAM chip in that position. So I'll get on with that. It's going to be easier if I just pause the video so I can see everything much clearer myself. And I'll come back and let you know what I find. Okay, guys, it didn't take me very far at all. I only read a couple more. On the fifth one, I'm reading this one here, B2, yeah? So we can see that that is from this corner. You've got a block of 5, 1, 2, 1, 2, and it's the fourth one down. Okay, so I'm going to measure that on my board. So I've got the block of 5, 1, 2, 3, 4, 5, 1, 2, 1, 2, and it's the fourth one down. 1, 2, 3, and we have a short. Yeah, and that's going to be in the RAM chip. It doesn't go to anywhere else. If we go back to our board view, we can just double check. But yeah, it just goes to the RAM chip. It goes to nowhere else on the board. So we can say straight away we've got some short-circuited RAM on this without finding all the rest of them. So that is a bit of a disaster, yeah, but worthwhile because that's what we've got. So guys, we can say this is a donor board, yeah, this is not going to be repaired. So this is the first one out of the batch of 13 I've actually failed, and I'm going to declare it as not economically repairable, okay. I'd have to change all the RAM, I would say. I mean, I just found one, straight away I found one short, and those only go to the RAM, yeah. So the chances are there's more than one RAM chip, and that was not the same layout as mine, so I can't say exactly. I just know that was one of the data lines going to one of the RAM chips because this chip is the same, yeah. So okay, I'm not going to make any money from this, but it's a donor board now, so I've got stuff I can use off it. Obviously not the RAM, but you know, I can use inductors and FETs and stuff off it. I think it's fairly obvious what happened with this now. There was a RAM failure, and then somebody with not enough experience thought they could fix it. Yeah, I mean, if they'd run a RAM test with mats, I'm sure they would have found a problem with this, and this would then be repairable, okay? So that's the first observation. I think we can say what went wrong with it. The second one, this technique I've just used to prove I've got short circuit RAM. You can also use this technique to prove if you've got short circuit or problems in the mem controller. So you can take the memory chips off, find the data sheet for the RAM chip, and then you'll find all these DQ lines, yeah. And again, just by measuring the resistance to ground, in diode mode, measuring the voltage drop to ground from each pin. They should all be the same, and if they're not, you can say I've got faulty memory controller. So you can use the same technique the other way around as well. It's a shame, but that's what happened. Other observation, I think we can say for certainty that this seller is not an honest person, okay. The other ones I think so far have been very honest. This guy actually told us what allegedly happened with this, and that is blatantly. He's a liar. He's a liar. I'll not repeat it. This guy's a liar. Okay. I've been thinking actually, and I'm going to suggest this probably applies to me, but if somebody else wants to be wants to stretch the truth a little bit, when I buy boards, I normally now I'll buy the board in auction and I'll wait till it's arrived or it's definitely been sent, and I'll contact the seller and I'll say, oh, by the way, if you're interested to know what happens with your board, I've got a YouTube channel and I repair them and I teach people to fix them, and this is the link to my channel. Yeah. And generally people come back, if you do reply, people would sort of say, oh, that'd be interesting. Yeah. Some people just don't reply. I haven't had any particular shirty replies off people, but I wouldn't be surprised to get one sooner or later, because I don't specifically say whether I'm actually going to, you know, I can say, look, I can link to the sale and say this is what it was, and this is what we got. Yeah, a bit like McDonald's. Yeah, this is the picture on the screen, and this is what I got. Yeah, you're dishonest. So I've thought now maybe to filter out some of these liars, is to, when I'm bidding on stuff, message them and say, oh, can you give me any more information about this board, because I'd any extra information will help me to fix it, you know. And by the way, I run a YouTube channel. I'm going to feature your graphics card on a repair video to all my subscribers before I bid. And if I then find possibly people are cancelling my bids or rejecting it or not selling it to me, then it may just be because you think their name is going to be up in neon lights on my channel. Their profile eBay is going to be on there, yeah, and maybe they'll be thinking better of it. So I don't know. I'm going to try that technique on all the future ones I buy. You know, oh, hey, I can make a video with this. You know, it's going to be famous, and then see what people's sellers' reactions are to that one. Yeah. I don't know what you think about it, guys. Maybe comments in the comments below. Okay, so this is not going to be repaired. I'm going to cut my losses at this point on it. I'm sure I'll get some useful bits off it. Hey guys, you can't win them all. I can't win them all. You can't win them all. So when you get to this situation, there's nothing else you can really do, to be honest about it. Okay, so see you all soon. Adios amigos, or should I say adios chicos. Ciao for now.